Okay, welcome. I am Pablo Tesone again. I am going to present some news update, really new and shiny update for Bloc in Pharo. This is a work that we have been doing, especially Martin has been doing a lot of it. He has been paid by the Pharo consortium with the contribution of the Thales to improve this graphic layer in Pharo. And well, we have a really nice results of this collaboration, so we are really happy. So thank you so much, Thales, for helping us to continue improving Bloc and making it a nice reality. What is Bloc? This is a really little introduction. The idea is that we need to have a new low-level UI infrastructure that allows us to generate applications that we can create only with Pharo and Bloc. That's applications that are custom, that we can draw ourselves and use a new UI, create a new UI to generate not only graphic itself, but also the interactions with this graphic, the elements, the compositions. It's a really interesting framework that has been a lot of time in development and also has a lot of nice concepts, and it's getting really mature and really to use. You have seen different examples of applications, especially done by Thales, that are incredible using using Bloc, so it's really cool. Basically, in Bloc, what we have a framework that models all the elements, the visual elements as VL elements, and then we can set different properties to it and different ways of composing it and including one inside the other. We have the different concepts like geometry, that is the shape of the element. In this case, we have one that is a polygon. Also, we can define border, background, transformations, like a matrix that skew and translate the VL elements. So we can, like that, manipulate these graphic elements and compose them to do different and really powerful graphics. We have a lot of, for example, a lot of improvements in the way that we can describe how is the border or the outskirts of a VL element. It's really flexible in that sense. Bloc. We have different ways of defining how the different lines or the borders and the caps are drawn. That give us a lot of flexibility. For example, we can the same shape can have completely different drawing depending of these properties. Of course, this is a really small introduction. If you want to see more details about it, we were talking much more about the API and the work that we have been doing the last year for improving it. So you can see my presentation myself doing the same in last year ESUG. So this is like a little introduction of what Bloc is. Now, an important thing about Bloc is that we have an architecture where the last year we introduced a new rendering engine that is basically taking full advantage of Cairo. It has been optimized a lot to use all the specific of Cairo. Martin, in this sense, has been passed from I know something of Cairo, I have used it once, and try to be an expert, and we can ask him, we want to do this, look, there is this way, or this is the appropriate way in the documentation, or this is the appropriate way to optimize it. Also, we have got a lot of feedback from Thales people that also are expert using Cairo. So we have taken all this knowledge and all this rendering, all this handling to improve the rendering using Cairo to generate what we call Alexandrie, that is basically a really low-level API, very close to the API exposed by Cairo itself, but with some nice features by using on a Smalltalk library. And with this, on top of Alexandria, now we have Bloc that can render a really good speed and have a good results. Also, we have added Hardbuff, but that I will talk later on why we want to have an additional library and why we are paying it. The price of having an additional library is open source, but why we want it. So let's go to the 10 things that you need to know or you need to see of Bloc in this last year of development. Well, the first really nice announcement is that we have a new alpha version that has been released. The idea is that in this new release that has been done hours ago, we have a lot of closed issues, and we have fixed a lot of problems previously. We have exposed more of the Cairo library directly to Alexandria, so like that is better to be used, because basically what we have done the last year, I will say it in two phrases, is that we have taken the Cairo has different ways of doing the things. For example, if you want to draw a rectangle, you can draw a rectangle drawing each of the points of the vertices, then drawing each of the lines connecting, then drawing the background, then drawing the borders or the things. Or if your rectangle enters in the majority of the cases and it's just a rectangle with a simple background, you can use a single function that is, draw me a rectangle from this point, drawing so height, so width, and with this color of background. And that is much faster than doing the complex way. So what Alexandria do is basically taking what you are trying to draw and say, your rectangle is quite simple. I will use the simple path. Your rectangle is really complex. I will do the complex path because you want a complex thing. Well, let's pay the time to do it. So like that, what Martin has done is continue adding all these shortcut optimizations that Cairo offers to get better and better results. Of course, there is a trade-off on all of these, so we have to handle the complexity of this. But that gives us a lot of good feedback and good results. We are adding more and more, exposing the completeness of the Cairo library, and we are working also to remove the old backend of Athens that was good, was working, was rendering correctly, but it was naive because it was not using all this optimization path. For the ones that do not know, Athens is our high-level API for rendering. It's not the fastest in around, but it's a wrapper on top of Cairo that allows you to do things in a more nice way than thinking about Cairo. But if you are a user of Bloc, this all is just a comment, because Bloc is on top of Alexandria and handles all the complexity and gives us a nice API that we can use and profit of it. Yes. Then we have this show of really nice applications that has been developed this year on using Bloc. In this case, we have a series of games that has been done by Enzo. As you can see, we show animations, layouting, different features in Bloc, and well, this one is the same application I showed it before, but with some graphical improvements in the latest version. And we can see the set of menu and widgets that is the new set of widgets that we are working on also with the support of Thales to have available. As you see, we have animations and things for doing a game, a really nice game. And also we have widgets, and you can see that the behavior is so nice also to have an application written with widgets done in Bloc. This is the widgets, just as a reference, is called Toplo, and it has a lot of features. Steph already showed some of them, but it has styling and skinning, and it has a lot of nice features that we are working on. Still is not usable, or yes, you can, but it's still in a state that we are going to continue evolving it. Other thing that Martin has done with the Milton Mamani is to produce a nice backend for Rosal that is rendered using Bloc. It's much faster and smooth than the one rendering on top of Morphic. Well, this is exactly the same application shown by Thales, so you already have seen, and another game that shows the feature. Sorry, it's restarted. Another Minesweeper. We have two Minesweepers. One of the nice things that Martin has been doing that have improved a lot the performance, this is a really nice news for the people using Bloc, is the ability to have rendering in layers that we can compose differently. Now it's using the layers as Cairo surface. Still, we are not profiting to have the composition at the GPU level, but that is something that Martin has in the pipeline, how to improve it, because even without having it and using the composition at the CPU level, we have a really good improvement in speed. I will show some benchmark later. The idea is that we can split our rendering in different elements and only rendering those elements when they are visually changed inside, or when we force the rendering of them. And it's from the API point of view, if you have a complex Bloc model, because in Bloc what you have is as in many other visual frameworks, you will have a tree of elements that are composed individually. So what we will take is, okay, this element represents a window or a section of my program, or a section of my visualization, and like you can say, okay, you will be rendering as a separate composition layer. So like that, this element and all the included inside, all its children, will be rendered once and catch it automatically. This is done directly by Bloc with Alexandria in the middle, but it's handled directly. For example, with this we can get really nice animations that are really smooth. This is a capture that we have done. I will show then later a benchmark showing FPS and data. But in this case, as you see, we can move and we can translate the different elements that has been rendered once, that they are the containers at the right, and they are rendered only once, and the composition is done at the level of Cairo and SDL. If we see these are some benchmarks that are look simple, but they are quite demanding, because they are drawing the same frame, but moving it, translate it down, and with a lot of elements, and elements that can be with a blur or can be more complex, like the ones that we have on the right on top. And we can see that the improvement by using the composition layers goes from almost 2 times to almost 9 times in these benchmarks. You have there the information about the benchmark. There are more benchmarks. They are the ones that Martin selected because they were the lowest improvement and the biggest improvement. So, but all the benchmarks got improved in this side by using a better composition. An interesting thing that we have been working a lot with Martin was to add the hardbuff bindings and to support the encoding and to handle Unicode in a more proper way, especially when we are using fonts that support it. Hardbuff is a library that allows us to correctly interpret the Unicode characters and combine different glyphs from a font when we need to do it. For example, if we are using, depending on the fonts, there are fonts that have, like in this case, liaison between the glyph, and that helps the readability, and that is nice. Of course, this is the font. This is nothing special. It's the font that we are using in Pharo now to show our source code. But if we render it correctly using hardbuff, that takes and say, if we have two letters that are friends with each other, let's call it like the F and the T that can be merged, it translated it to a different glyph, to a glyph that has the two letters combined. The same happened, for example, in this nice font that now is a la mode with Visual Studio Code that renders the arrows, translate the ASCII characters to those nice arrows. And this is all done by hardbuff. Basically, what we do is that we take the stream of Unicode characters, hardbuff analyzes it, applying it, and taking in account the language that you select, the font that you are using, and the orientation, if you're writing from left to right, right to left, and do some transformations. And if it has a specific transformations, we'll update your stream of UTF characters to show the ones that you want. Then later, Cairo is the one that do the rendering of the specific glyph. This one is really cool because before we had support for emojis. We have shown it last year, but there was a feature of the emoji standard that we were not supporting, that is the combining of emojis. Emojis can be combined, and also this happens for characters that are in different characters. For example, the accented letters in some fonts are combined combined Unicode elements, and this is handled by hardbuff. In the emoji is clear. In this case, we have a special Unicode character that is basically the fourth person in a single emoji, and you can combine with the other existing emojis that represent the faces or any of the emojis. You can combine them in four, generating a new character that is combined. This is solved by hardbuff and Cairo, and allows us to render correctly the totality of the emoji standard in the Unicode library. One interesting thing that we have done is that we have been upgrading and rebuilding all the native libraries that we are using, all the external third-party libraries that we are using. Why? Because we need to have add hardbuffs, and then we have to have the same version of all the libraries, so that easy the maintaining and the evolution of Alexandria. Because if we want to use the optimized versions, for example, in Cairo, we want to have that functions present in all the versions. These are the versions that we are using now. This simplifies the Bloc installation, because now Bloc only for installing it only requires to install Smalltalk code in your image. The dependencies, they were already there in the VM, because these are not, we didn't add any new library except hardbuff, because Cairo, FreeType, SDL, they were there because they were used also by the Morphic backend. But we have a single set of versions for all the platforms. We have a consistent results in all the platform. And also we have a speed up in some of the benchmarks that we are using, because we are compiling correctly the libraries to support hardware acceleration and to support the latest OS support. For example, in Mac OS, the Cairo now uses a newer version, or expect to use a newer version of the Cocoa framework, and like that is using the acceleration and the metal engine, and it's faster. For example, just by improving the version and building it correctly in Mac OS, we have got an improvement between almost 2 times and almost 5 times in the benchmarks that we have in the system. One important thing that Martin has done is that we like test, as we like in all the systems, but we are here in a system where we have something graphical and we need to compare the results, because if we do it correctly, we have the correct rendering in all the in all the platforms. We have a expected result, an expected result and an actual result of the execution, and we need to compare them. So Martin, what he has done, he has, I don't know, what he has done is that the test will produce the rendering. It will compare it against a known good render that what we are expecting in all for all the platforms, and it's doing a comparison and generating a comparison that give us that when it generates and we have a difference between the comparison, it's generating the result as a fuel file that we can load in Pharo and compare visually the results, why they are not passing the test. The first comparison is done automatically, and then as we can check the results, the expected with the actual, to see, look, it's not correctly rendering this or not correctly rendering that. For doing that, what we have is that we compare the two images to find the results. Also, this idea has been done with the handling of events, because we have some events that should happen in different places. For example, when we have a BL element and it has a border, or it has something that is on outskirt and goes away, we have to handle it and handle correctly the events when we click on it, to include the whole area with the transposition on. Look, for example, I don't know if here is my mouse. I don't know. Well, here in the example on the left, in the element that is transposed and scaled and rotated on the right below, well, the mouse should act on all of it. Doesn't matter the transformation this has done. For this, what we have done is that Martin has written, has fixed the error, but also he has written tests that allows us to generate the heat map of the mouse on a given set of examples, so we can test it and have the regression to check if we don't have this problem anymore. This is cool because we have invested a lot in trying to solve problems and automatize the detection in test of problems that usually requires human interaction, like from seeing 2 different images or to try where is the mouse overreacting in this widget. Well, then there is a better drawing of the rectangles, and is better following better the CSS idea. It was an issue that is nice, and also the rectangles correctly, or the borders, when they have overlap corners, they have to render correctly when we scale them. This was a problem. This is something big that we have been working on recover and having a better SVG import. We take an SVG file and generate the BL elements that generates them and translate, for example, the path and the different elements that are part of the SVG standard and how they translate directly to Bloc. And we have a nice import from SVG. And also, we have a really nice export support of SVG and PDF by using the support that we have in Cairo, because as we are rendering correctly the elements and helping Cairo to render correctly, we can generate the correct set of elements when we are exporting. Other thing that was missing and was one of the things that make it look like that Cairo was not a good idea is that some shadow effects were not present, but what we have done is that we have implemented them, even if we are implementing them now using the CPU, and most of them using, no, most of them no, 100% of them generated with Smalltalk code, we can even get a really nice performance of it. You can check the set of benchmarks. There are benchmarks for mostly all the operations, the graphic operations that we can do with Cairo. The same for the gradient in border. This is it's a real animation that we have taken from Bloc, and we can have linear and radial gradient also on the borders, because before we were having beautiful linear and gradient renders in the interior part of the sea, but the border was black and not changing, but now it follows the same gradient. So thank you so much. This is the set of news and improvement that we have been doing. Some of them are hidden in the back, because most of them you will see when you see the performance improvements in Bloc. We have not added too much new rendering features. We have not added too much new rendering things, because already the last year we have covered mostly of the requirements of Bloc with the new Alexandrie backend. So now we are in improving the speed and doing better testing for not having regressions or any kind of problem. If you want to use Bloc, it's highly recommendable. It's stable, can be used nice, can be used for applications. We still are working in the widget set. The widget set is not production ready. You can try, you can use it, you can play with it, you can help us to design it, but Bloc ES is in a good shape. There is a mailing list that if you are willing to talk about Bloc or have problems, is a nice place to go, or the Bloc channel that mostly of the time Martin is there, so you can get feedback, direct feedback from him, and well, those are the repository. And of course, we put Alexandrie just because it's the backend. Maybe for somebody doing something really low level can be useful, but Bloc gets using Bloc, you get a nice abstraction layer that it works quite well. So thank you so much, and thank you. Is there any question, any comment? Yes.
In terms of drawing the rectangle, you're saying it's faster. Is that now from a point of view of development time or actually rendering time with the new?
From the rendering time, because what it has been done now is that we need that is completely hidden from the user of Bloc. If you use Bloc directly, you don't need to know these differences. What Alexandrie do is that when Bloc requires to render something and says, I want a square like this, Alexandrie takes this information and says, look, this square has a background, so I will render like this, or does not have background, I will render like that. It's maybe it's not the the sexiest code in the world because it's doing a lot of conditional code, but it's structured in a way that is using combining blocks. So like that we can combining code blocks, closures, and like that we can say, oh, okay, execute in this way or that way. So for a rendering, that is all hidden behind block. Yes.
There is one thing I'm not sure to have understood is that Alexandre should replace Athens, or will Athens will use Alexandre? Because you said that it should replace it, but on the slide it was
Yes.
written that we can do an Athens backend with it.
Yes. It replaces and it will be used as a backend in the two sense. Because in the previous versions of Bloc, Bloc was using Athens to draw the things like that at the end through Cairo. Okay, so why? What is the feature that Athens give you that Alexandrino does not give you? Is that Athens is more friendly from the point of the programmer. You will have a builder, a canvas that has a state, and you can configure it and use it, and is easy to use. It has this is intended to be easy to use from its conception, from its idea and design of the API. Alexandria, on the other side, is designed to be fast and to try to use all the features present in Cairo. So what will happen eventually is that we will have, from the point of view of the user, if you want to have a rich model with a block, you will use Bloc. That Bloc will use Alexandria. That Alexandria will render with Cairo. If you just want to generate a PNG with really simple or a simple PNG that as we do with Athens now, you will continue using Athens in your code because it has a clean API, it's easy to use, and Athens will use Alexandria that renders on top of Cairo. And for example, for Rosal covers other stage that is for doing visualization, for doing charts, for doing the navigation, that's the navigation, how scrolling, those features can be implemented on top of Bloc. So the idea is to have a single stack of graphic libraries or frameworks or graphic composition tools that we can plug what we are doing depending in the level of abstraction that you need. For the final user, the highest level of abstraction, if you want to do, is using Bloc or using Rosal. And then in the meantime, that will use the other layers to render directly. Yes. Yes, Alex. Yes, yes.
This is really great work. I have a question regarding the algorithm, whether there is an algorithm that says whether a point is within a particular shape. So maybe there was implicit when you talk about the heat algorithm, but is there a way to know whether the point is within or very close to a shape? Like we had this problem where you had some Bezier curve.
Yes.
And you don't know how to select them with the mouse because the Bloc is good at rendering, but it doesn't really directly tell you where the point is in that shape.
I don't know exactly the real implementation, but I know that Martin is using the implementation that is present in Cairo, because Cairo already had the functions to know if when you render a shape, if it's can give you the correct bounds after the translation and the squee on all the matrix transformation. You will need maybe to ask Martin, because it's outside my knowledge. Yes.